Good afternoon. Today we're going to continue with operator overloading. So the first thing I'd like to do is review the concept or the idea behind the plus equals plus operators that we went over last time. And we'll do that by implementing times equals. Okay? And this is sort of mimicking what you're going to do in your homework assignment for the polynomial class, which is you're going to implement a plus equals function, a times equals function, and then you're going to use those functions to write the other parts of the code. Okay, so plus equals, times equals, they're going to have the exact same structure, but they're just going to perform a different algorithm on the internal variables. Okay, so remember we've got this idea here of a plus equals function, and I showed you guys last time we started out with a plus equals function, like what you had on your homework. And then at some point, you see down below here in the code, I demanded that we get rid of it altogether. See this plus equals? And the reason is because this is a numerical function, I only want the plus equals code to appear in one location. And I've determined that having a plus equals operator containing that set of code is what I want out of it. That's the desire that I have for it. Okay? So to have two versions of it, one called plus equals, another one that's the operator plus equals, it might be a little confusing, in particular if I have duplicate code. And of course you might say, well, why don't you just have one of them call the other one? I could do that. But I don't want there to be a plus equals function. Okay? In fact, I want to force whoever is using my fraction class to use the plus equals operator, operator plus equals. I don't want them to write code that looks like f dot plus equals in words. Okay? I want them to use the syntax that I've developed. Okay? And there might be many reasons for this. One reason in particular is there is always in the background this issue of how readable is your code. And if you implement all of this functionality and people only know about a small subset of it, they might write code that looks horrible and think, wow, this library is not very good. Okay? So that's the reason why I'm going to force you not to include the plus equals function in words, and I'm going to force you to just go with the operator plus equals. Okay? So that being said, let's do the same with operator times equals. And again, the emphasis here is not, oh, gee, how do I multiply two fractions together? Okay, everybody knows that. Okay? The question is, how do I logically structure my code so that I don't duplicate code and that I can sort of utilize the class public-private structure as effectively as possible. Okay? So again, remember, we had this operator plus equals, and it returns a fraction reference. Same thing is going to be true for times equals. And it's going to accept on the right-hand side a const fraction reference. And this makes sense, right? If we're going to write f times equals f2, f2 is going to stay the same, and f is going to be the one that gets modified. It's not going to be a const, right, because f is going to get modified. And then for a non-member, the non-member operator times is going to be the usual binary multiplication operator. Okay? So we've got two operators here. One is something like f times equals f2, and the other one is something like f times f2. All right? Same exact idea as with plus equals and plus. Now let's go to the code. Okay. So I'm going to just copy and paste the whole thing. All right, so I changed this operator plus equals to times equals. And then, of course, fraction multiplication is a lot easier, which is just a times c over b times d. Multiply numerators, multiply denominators. We'll keep these definitions here and then just make sure that the code is readable. And again, like, you can do little things like this. Little things like this don't matter, right? Extra spaces, return carriages don't matter, but it makes the code a little bit easier to read and to parse, right? So just, feel free to throw these little flourishes in there. You want to structure the code so that it's readable with a minimal amount of extra effort. Okay, so again, the important thing here is not the actual multiplication of two fractions, how that logically works. The emphasis here is on the input-output structure. You're passing in the right-hand object by const fraction reference, and you're returning a fraction reference. Okay. We'll do the same thing for operator times. And this is the beauty of it. I mean, look, you just go back in here, you just change a plus to a times. Everything stays exactly the same. Okay? Again, once you've defined what times equals does, then defining operator times in terms of times equals allows you to make this operator non-member, and it doesn't actually access itself any private members of the class. It simply calls a public member function of the class, in this case the operator times equals. The other important thing about the way this is structured, and this does differ from the example in the book. In the book, the example does a const fraction reference here and a const fraction reference there. I think it's in chapter 14 it does that. I'm changing the game here. I'm changing the style. This is a new form of style. Speaking of which, I posted a link to, there was a Stack Overflow question and answer precisely on the topic of operator overloading. That's the style I'm following. There's the answer with the most upvotes. And this answer was, I believe, converted into an article and published somewhere. I don't know the details on that. But everything in this response is what I'm basing the style for these first few homework assignments on. Okay? So it's not in the book, but it is on the web. And you should be always curious, oh, it's on the web. Okay, yeah, that's a good reservation. But what I'm telling you is, yeah, in this case, this one looks good. Okay? And it's not just me. It's hundreds of programmers and internet users who have basically said, yeah, this seems like the most logical, reasonable way to do it. Okay? That's very powerful in programming. Programming is very much about peer review. It's about everybody looking at it and saying, hey, well, here's an idea. What if we did it this way? And then discussing it, challenging it, coming up with all the caveats to that solution. This particular style is the one that is pretty much championed right now. Okay, so that was a good review. And now this gives us access to, basically, let's just do times, throw in times equals, print, we'll do here, we'll do a times, there we'll do a times, everywhere, except there, a times. Okay. Compile, and we run, and then we've got 5/11 times 2/3 is equal to 10/33. Seems about right. We take 10/33, we multiply by 2/3, we get 20/99. Also seems right. And the negative 2/3 is left over from just the minus operator. Okay, now why do we do all this? Let's take a stroll down memory lane. Okay. Int a equals 5, int b equals 7, int c equals 10, int d equals, watch this, wait, a, will this compile? Yeah, this will compile. Okay, and the reason this compiles is because, okay, so that, let's not think about why that compiles right away. Okay, what is the value of d going to be? I don't know it exactly. I'm pretty sure it's not going to be 5, though. Okay. It shouldn't be 5. It's going to be something large. Okay? There it is, 69. Okay? Definitely not 5, definitely not 7, definitely not any of the variables initially defined. Okay. What the heck is that line of code doing? Okay, let's simplify it, for example. Okay, so let's see. Do you know what this is doing? A plus equals B. Yeah, okay. What if we did this? Let's get rid of all this extra stuff. Will that compile? Yeah. Okay, now let's think about, all right, this should probably output something along the lines of a 5 or a 7 or a 12 or something like that, right? Let's see what D actually becomes. 12. Okay? So where did the 12 come from? 5 plus 7. Okay? So what this is telling you is that the order of things that happen is you have D equals A plus equals B. So A gets updated to 12, and then it gets stored. That value 12 gets passed along to D. Okay? Now, what is A going to equal after this line of code? 12 as well. Okay? Now, what if I did this? Well, okay, let's see. That D equals 12. What if I did this? Now what do you think? Take a guess. Say it louder. 22. Do I have anything else? Yeah, I would agree with that. Let's see if we're all wrong. Okay, we're all right. Excellent. Okay, D equals 22. Okay, so what this is actually doing is the following. Here are the steps. It's saying, okay, D equals A plus equals, and the first thing it's doing is B plus equals C. Now, when it's done with this, it's actually returning a reference to B. Okay, so it's performing the arithmetic, B plus equals C. In other words, it's calling the function some variation of its own operator, plus equals. And it's not just returning the value 17 in some temporary. It's actually returning a reference to B itself. Okay? That's why we return the fraction reference in our operator plus equals. We're getting the actual object or variable itself rather than just a temporary variable with that value stored in it. Okay? This way, now when we do A plus equals B, the next thing that happens is so it performs the addition, and what does it replace the parentheses expression with? A. And then finally, it sets D equal to 22, because A is also equal to 22. Okay? So that is the order of how things work. Okay? Now I'm about to blow your mind. Okay. How do I want to blow your mind? Okay. So let's get rid of this stuff for now. All right, here we go. Watch this. Watch this. Will this work? Oh, question.
Quick question. So does the value of A change or only a copy of A?
Very, very good question. Very, very good question. All of the objects, A, B, and C. So does anything happen to C? No, regardless of whether it passes back a reference or a temporary, C is all the way on the right. C doesn't get touched. C gets used and accessed, but nothing changes. Now, the question then becomes, okay, well, if it follows this logic that I've explained to you, then it should call B plus equals C next. That should do what to B? That should modify B or update B to whatever, okay? And then it's going to return, like I said, a reference to B in the next line. Let me number these. What's these here? this one. Okay, so we get a reference to b in line 2. Okay? But it's an updated value. B's already been updated, and we get it back. We get its updated value back. And then we use that updated value of b in line 3 to then do what? Change the value of a. Inside the function, we update the value of a, and then what do we return? A reference to a itself. The newly updated value of a gets returned back to us. Okay? And then we set that equal to d. Okay? And again, all this is saying is, the last line 4 is saying, okay, well, a has this newly updated value. Just grab that value, and I'm going to just make myself equal to that value. Okay? So c is the only variable here that remains untouched. Well, not untouched, but unmodified. Everything else gets modified along the way. Okay, now, here we go. This is where the fun begins. First, let's start. What does this do? A equals a plus 1. Well, what does this do? A equals a plus 1 again? Yeah, actually, yeah. Okay, these lines, if you write them exactly like this with nothing else, will probably generate the exact same code. Okay? There will probably be absolutely no difference between writing that line with plus plus a or that line with a plus plus, as long as that's the only thing on that line for that statement. Okay? They'll do the exact same thing. But and in fact, I'm going to actually create 2 variables so that it's better to keep track. So int a1 equals a, int a2 equals a. Okay, so again, a is going to be 5, a1 is going to be 5, and a2 is going to be 5. And we're going to compare what are the values of prefix and postfix. Okay, now, is there a difference between lines 75 and 76? Yes. Okay? Yes. 2 different things will actually happen. If you didn't know that before, I'm telling you now. Okay? You don't really have needed to know this prior. Okay? Now you know. But that's all there really is to it for your prior information. They do different things. And we're going to want to overload plus plus operators for our fraction class, right? For our polynomial class. So let's try and understand what the input-output structure is, because these are essentially the same as plus equals or the minus sign. They're just operators, and we can overload them for our fraction class, and we want to do so in a way that mimics how they would be utilized by ints. Okay? That's the idea. So let's see. A starts out being 5. Now the prefix plus, let's just run this code and see what happens. The prefix plus prefix variable gets the value of plus plus a, and the postfix gets the value of a plus plus. So the question is, will there be a difference between these 2 values? And if so, what will they end up being? Okay, 6 and 5. So what does the prefix plus plus a do? It increments it first, and then it basically returns that newly incremented value. Okay? What about a2 plus plus or a plus plus? What effect would that have? Yeah, it returns the current value of a before the increment, gives that to postfix, and then increments itself. But how would that work? Well, I mean, think about it in the context of plus equals, right? With plus equals, we update the value of the variable, and we return a reference to that variable. All is well with the world. We wanted the updated value, we got it. Prefix, we can do that, right? Inside the prefix, the operator plus plus, we can increment the variable a and return a reference to a. We get the new value. We pass along the new value to prefix. But what about with postfix? You have to do the increment inside of the function. You can't do an increment outside of the function. Once the function's done running, it's done. So what do you have to do? You have to increment the variable a inside the postfix plus plus operation. Okay? But then what are you going to return? You're going to have to return a copy, a temporary value that contains the value before you did the increment. That's the only way to give postfix the pre-incremented value of a. Okay? So just to give you an idea, yes, indeed, there are different observable behaviors in prefix and postfix. And let me show you the style for them, and then we'll reconnect it with ints. So, okay, here's a funny thing. Here's a funny thought. Will this work? Check that out. That compiled. Line 81. Is that surprising? You ever tried to do this before? This is perfectly valid code. There's nothing wrong with this code. Compiles, runs just fine, completely logical, and you'll understand why once we do the more overloading. But what if I try to reverse it? Now it explodes. Okay? Compiler error. It says something like plus plus needs L value, whatever that means. Well, I know what that means, but I'm not going to cover it in this course. In fact, if you try to do two of them iteratively, okay, so you do a plus 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 plus, that also will not work. Okay, you can only do one postfix plus plus. But you can do as many sets of prefix plus pluses as you want. Just make sure you get an even number of pluses, otherwise it will give you an error. Okay? That's easy to show you. So this one's an error here. But if I add in just one more plus, that's an error. It's that extra little plus there that makes all the difference. Okay, so put that back. Compiles just fine. Let's overload operator plus plus, and I'll show you exactly the syntax for it. So first, the prefix plus plus, it's going to return a fraction reference, and it's just denoted by operator plus plus. Okay. Now, what are the input parameters for the increment operator? What parameters does the increment operator take? None. Very good. None. And none it shall be. Okay? So now let's define it down below. Let's put it in with the other fraction reference operators. So this is a member function of the fraction class. Now what should it do? It should basically, well, how would you add 1 to a fraction? Yeah. Is it just a matter of being shy, or is it? Okay, was it? Well, right? You want to do a over b plus 1. You do a over b plus, what is it, b over b? Yeah. No, sorry, I don't mean to be like, come on, guys, this is, sorry. I mean, like, you guys probably haven't done math in a very long time, and you probably all know it, and you're just too shy to say it, okay? So I don't want to come off like, you don't know how to add fractions. I don't care if you do or don't. This is a review of how you do it, okay? So, don't worry about, like, I haven't done any of this stuff in so long. Just be flexible enough to relearn what you need to know, okay? So here we go, a plus b divided by b. It's as simple as that. What am I going to do to the numerator? I'm going to add the denominator to it. Okay, so I can write something like numerator equals numerator plus denominator, or I can just write something like numerator plus equals denominator, and that's it, right? That's all I got to do. What does this assume, though? It assumes the denominator is not 0, sure. What else? What if it was negative? What if the denominator value was negative? Would it give you what you want? Nope. Okay, so let's make a critical assumption, which is what? Let's just say everything's positive. Okay? We can make that assumption, right? Well, I mean, we can say whatever we want, but then what we can do is we can make sure that our class contains the necessary functions to ensure that what happens. If our fraction becomes negative, either the numerator has a negative sign or the denominator has a negative sign, what can we do with the negative in a fraction? Yeah, you can always move a negative, right? If you have a negative in the denominator, what can you do with that negative? You can always move it to the top. So let's make the assumption that the denominator is always going to be positive. Then this works. And then we'll write another function that just ensures, after each arithmetic operation, that if a negative sign were to appear in the denominator, we do what with it? Move it up to the top. Okay? That's the idea behind class encapsulation. That's why you put everything inside of a class, and you don't let anybody, any programmer, any outside class, mess with the internal values of those variables. Because this function only works under what assumption? The denominator is positive. You can enforce that as the maker of the class. But if you give any other programmer access directly to the numerator and denominator, what might they try to do? They might try to make a denominator negative, and what would that do to all of your nicely, beautifully written code? Crash. Now all of a sudden you're the one who's to blame. It's your fault that this code doesn't work. Okay? So that's why, that's the need for the greater sense of security in the encapsulation. Okay? So again, we have to make a critical assumption that b is positive, i.e. denominator always positive. Okay? Then it works fine. Finally, I just return star this. Okay? Whenever I return a fraction reference, I'm going to return a star this. Okay? So that's great. This should work. Just compile it. Logically, it's correct. Okay, now, how would we do the postfix? Did I tell it anywhere that this was the prefix operator I was working with? Did I say prefix anywhere? Did I put the plus plus on the left side of the keyword operator? No. There's only one operator and then symbol kind of paradigm. That's the only way it works. So what you have here is a case of there are two different operators. One is the prefix, one is the postfix. They both go by the same name, which is operator plus plus. So if two functions have the same name, but you want the compiler to disambiguate between the two of them, what can you do? See? Yeah, you change the input parameters, right? And if one function called myfunc has no parameters and myfunc has 3 parameters, then depending on how many parameters get input, the compiler knows which ones to call. Now, there are no parameters for the operator plus plus. You don't input anything. So it's safe to just say, well, and here's what the compiler literally does. If there's no arguments, it calls the prefix. And if there's a int argument, it calls the postfix. That's literally how it works. Okay? You call them using prefix and postfix, plus plus versus a, plus a versus a plus plus. But the definition of the operator functions has to follow this type of format. The other thing too is we're going to get rid of this reference. We're just going to return by value. Okay. So let's okay, here we go. We'll do the same thing. Int, this is going to be unused. Your book suggests to do write int unused. I don't disagree. Okay, so the only thing it's complaining is that it needs to return a value. Okay, now how? Here's a good question. How do we? What should the postfix plus plus return? The value of the fraction, yeah, before the increment. Okay, so we have to do the increment inside of this function. So what we're going to do is we're going to create a new variable called, I'm just going to call it clone. Okay, so here I'm going to write fraction clone, and I'm going to initialize it using the same object that called the function in the first place. Okay, so how do I access the actual object calling the function? It's the same way we do, when we return this for the fraction reference? Well, we can initialize clone using precisely star this. Okay, so what this line does is it says create a new fraction object called clone and take whatever values were in the object calling this function and copy all those values into this new object. Okay? Each class lets you do this for free. You don't have to do anything extra to your class. It automatically comes with it. Okay? It's called a copy constructor. Question? So the question is, instead of star this, can you write numerator, comma, denominator? Yes, you can do that in this case. But, here's the thing. I'm going to write this function in such a way where it's going to be exactly the same, almost, okay, the only thing that's going to change is fraction is going to be replaced with whatever class you're talking about, and you will write the exact same code no matter what numerical type class you write. Just like operator plus right here, this is going to look exactly the same no matter what class you write. Just replace fraction with the name of the class you want. Will look exactly the same. Not only do you not duplicate code, you don't duplicate thought processes as well. Okay? You literally just copy and paste a format, a template in a sense. That's not the word a template I want to use, but just a recipe. And as long as you've defined those one or two key functions appropriately, then you know that if there's any bugs in your code, it's probably not in these out-of-the-box structures. It's in the actual functional code itself. Yeah, question?
So what's the difference between passing the value of this pointer into the clone instead of saying fraction clone equals the value of this?
Very good question. So the question is, what is the difference between this line of code and this line of code? That's the question? Yeah. Okay. I mean this quite literally. That's a different error. Let me just. The punchline is we're going to be returning clone. Let me just throw that in there. Okay. The answer is, what is the difference between this and this? Absolutely nothing. This will generate the same code. Because there are a few things in a class you get for free. Okay? One of them is a default constructor, right? So as long as you don't have any other constructors defined, you can construct an object by default, and it'll default initialize all its variables. You get a copy constructor for free. That's what I commented out right there. That will, and this is important, it will construct an object using the same values as the object you're passing in. Then you get an assignment equals operator. This will take an already constructed object and pass the values into it. Okay, copy over the values. So what ends up happening is, and this is really confusing, you might think because the equal sign is there that it's going to default construct clone first and then use the assignment equals operator, but it actually doesn't. It actually converts it to the version that's commented out. You don't need to know this right now, but that is the complete answer to that question, which is these are the same thing, but the first one is preferred, the one that I just commented out, because it more closely resembles the actual function that gets called and the actual code it's being converted to. Yeah.
Or just like an extension of that, so every time like you pass like a fraction in as like value, it's calling the copy constructor every time you're doing that?
Yes. That's why, without knowing anything about copy constructors or anything, you can pass in objects to a class by value because you get it for free. Yeah. Okay, so hang on one second. Let me just wrap this up by saying these two are the same. And then this one would be different. What it would be like fraction, clone equals star this. This would actually do the default construct first and then call the assignment equals operation. Okay? So this is what you would not want. This one would be different, not desirable. Construct object first by default, assign values from existing object. These two are the same. They construct the object with initial values provided by this. Okay, so oops. Okay, there we go. Okay, so I'll leave that code in there. And again, I'll post this code on CCLE. Was there a question?
Oh, no, you explained it right here.
Okay, great. Good. Okay, so I've gone through all this trouble just to make the copy. All right, so we made a copy of the current value. We are, in fact, going to return the clone. So what's left to be done? Actually incrementing the object. Now, no. Here's the thing. Could I write numerator plus equals denominator? Could I write that? Would that be, in a sense, correct? Yeah. Is there a better way to do it? Yeah. So if I've already written the code numerator plus equals denominator somewhere else, the question should immediately come to your head, well, can I just call that function instead? Because that way, in case anything changes, there's only one location that I would have to go to make the change. Okay? If anything goes wrong, there's only one location I would have to go to make sure that I did everything correct. Okay? And so the answer is, well, how do you call it? All right, well, you want to call what on the... So we're going to take star this, and what are we going to call on it? Yeah. So we've just defined the prefix plus plus. That actually does something to the private variables. Okay? It actually does do the increment, that numerator plus equals denominator, and it returns a reference to the actual object itself. Okay? Now, what did I do here? In the postfix operator plus plus, all I'm doing, I'm not actually writing any mathematical numerical code. It's just logical structures. It's saying, I've already done this before. I'm just going to access it. How do I access it? By calling prefix plus plus on the object itself. Star this is a placeholder for the actual object calling the function. I've made a copy of its value. I'm saving that copy. Now I'm going to increment it by calling a function I already wrote, and then I'm going to return the copy, the pre-incremented copy. So another way to do this, so this compiles. Another way to write this is the following. This arrow operator plus plus, okay? Right? Because I defined an operator plus plus function. That's what it is up there above. It accepts no arguments. Remember, this is a pointer to the fraction object that's calling this function. Okay? What's another way I could write this? How about star this dot operator plus plus? Okay? All three of these do the same thing. The one that's actually preferred is this one. Okay? This is the one that's actually preferred. This with the arrow. Okay? Now, is there anything specific, and this is now the key about it, take a step back, let me ask you a question. Is there anything specific to fraction in the code here? Not really. Right? If I replaced fraction with any other class type, as long as I've defined the prefix operator, this should do what it's supposed to do. Okay? So, let's see. This is the epiphany that you should be having, okay? Which is, I can copy and paste the code from here to here. I can rewrite this code. I can rewrite it over here. But the actual lesson here that you would not learn just by doing it yourself, but that you would actually get by a directed study, is to say, is there a very organized way of doing this that lends itself well to further, extending this code to other scenarios, writing other classes, things like that. Okay? So again, the only thing that actually does the increment is the prefix plus plus. The postfix plus plus calls the copy constructor. Every class gets one of those for free. It calls the prefix operator. We're assuming that's been defined. And then finally, it just returns the copy. Okay? So this is the utility of it. The utility of it is in the genericity of it. I don't know if that's a word, but the generic nature of this code. Okay? Not the fact that it actually multiplies fractions together, things like that. Okay? Does that make sense? All right. Let's go back to main. Now, let's forget about variables a through whatever. Let's write fraction. Well, okay, let me keep all of this code here so that you can play around with it later. Now, let me create fraction a1, say 2/3, fraction a2, 3/4, fraction b1 equals, say, plus plus a1, fraction b2 equals a2 plus plus. Okay, and actually, let's make a1 and a2 to be the same value. b1.print, b2.print. Okay, what should each of these print? What should b1 print? 5/3, right? What should b2 print? 2/3. Let's check that hypothesis. Yeah, 5/3 and 2, and it's all strung together. Let me write cout window. Okay, there it is, 5/3 and 2/3. Okay, so we get the same idea. Okay, now here's something we didn't check last time. Well, what if I try to do something like fraction c1 equals a1 plus equals b1 plus equals a2 plus equals b2 plus equals a1. Will this work? Should it work? What do you think? Yeah. Well, what should C1 be? I have no clue. Let's find out. Oh, let me It ends up being 1782 over 243. Okay? But the way we've set it up, you know exactly how to interpret this statement. It's the exact same way to interpret it as if they were int variables. Okay? Now, here's something maybe a little more surprising. Okay? What would happen if I do fraction d1 equals, let's have some fun, a1. Let's see, are there an even number of pluses? Apparently. Okay? Now, what should d1 be? Let's get rid of this one. Okay, what should d1 be? d1 should be the value of a1 incremented, well, half as many times as there are pluses, right? So each set of 2 pluses corresponds to adding 1. And we ended up with 44 over 3. Okay, so each set of 2 pluses corresponds to adding 3 to the numerator. It started out as a 2/3. It started with a 2, and we ended up with 44. So is that right? So 42, how do you get 42? That's what? 42 divided by 3 is, which one? Oh, and I incremented it once, exactly, with the fraction b1. Yeah, good eye, good eye. Okay, so that works, and you understand why that works. Okay, now all right. There's actually a difference between an int, which is a fundamental type, and an object. Okay, so this is something that just might surprise you. Okay, fraction d2, well, let's call it e1 equals a1. And I'll put in a bunch of pluses. What? It compiled. Okay, let's take out the d1 part. Now, what should a1 be? A1 should be 5/3, right? Because fraction b1 increments a1. In line 95, fraction b1, a1 becomes 5/3 after that line is run. Forget about b1. Now, e1 should be, well, that shouldn't even compile, right? If this was ints, that wouldn't compile. But it does compile for fraction objects. This is the difference. Ints are fundamental types. Fractions are objects. Temporary fraction objects and temporary int variables are handled slightly differently in C++. Okay? Let's see what this does. Okay, so let's call e1.print, and let's see what actually gets printed out. 5/3. Okay, well, what the heck is a1? Well, what should a1 be? Well, let's see what it is. a1 is 8/3. So what it's actually doing is the following, and we'll end on this. What's actually happening is when you do the postfix, the postfix plus plus gets interpreted the following: a1 plus plus, and then plus plus, plus plus, etc. Okay? Now, the first thing that happens is, what function gets called? Postfix plus plus. What does postfix plus plus return? The original value. It creates a new object with the original value. And then, what happens to a1? a1 is completely out of the picture. Okay? a1 is no longer in this chain. What ends up happening is it looks like in the next step, it looks like temp plus plus. Okay? Now in int temp, you can't call plus plus on it. But a fraction temp, you can. Okay? So while we're designing our operators to mimic the behaviors of ints, or maybe doubles if it's a different type of numeric class, they're not the same. An object is inherently different from an int or a double, which is a fundamental type. However, if it compiled for ints and doubles, we want to say the same thing will happen for our class fraction. If it doesn't compile for ints and doubles, then whatever happens for fractions we'll just ignore. Okay? Even though it does compile, you would never write that code analogously for ints or doubles anyway, so let's just ignore what it does. Okay? It has the desired effect when all of the operations that are valid for int would be applied to a fraction object. Okay? So okay, I guess I lied. Friday is when I'll introduce the reduce function, because we will definitely need that to make sure that our plus plus operator works, to ensure that our denominator is always positive. And we want to make sure that we're in lowest terms, so that when we use the operator equals equals, when we test if two fractions are equal to each other, we can avoid a certain type of numerical overflow. Okay, so we'll start with that on Friday.